So let's talk a little bit about measuring and marking for our layout. So everything really is informed by the materials first and foremost. And that decision has brought me to the choice of using something that has high capacity for strength, that has the length and diameter that's consistent with the kind of requirements that I'm expecting of it. It is quite common that when people are doing construction with materials like 2x4s and 2x6s and 2x10s and 2x12s, that they are often using what are referred to as deck screws to make those connections. And deck screws are different than general purpose screws or drywall screws like this, in that they're made out of either stainless steel or high-grade steel with an epoxy coating on the outside of them to minimize the oxidation or rusting of those fasteners. Because this is outdoors and it's going to be exposed to the elements, fastener like this might rust through in a couple of years. A stainless steel screw like this is going to extend that life of the connection far beyond the life of the materials itself. But one of the challenges that I'm dealing with is that because I'm anticipating heavy loads, I know that this type of screw is not strong enough for what I'm trying to do. So I'm going from this stainless steel deck screw up to what we refer to as a lag screw or a lag bolt. It has a hexagonal head, and I've equipped it with a washer. And it's important that you understand that when we're using fasteners in applications like this, if we do not use a washer, then that fastener is going to tend to bury itself down in the wood. And where that is something that is often desirable when we don't want to see evidence of that fastener, in this case, I'm going below the grade of the surface and then using a washer to keep that fastener from pulling down into the wood, so it's spreading that load over more surface area. So this is actually the backside of my piece that's getting mounted to masonry, so I couldn't have the bolts sitting up above the height of the material because I wanted it flush to the surface of that wall. So I'm going to be drilling 3 holes. My first hole is to create the pocket, and I'm doing that with a type of bit that's generically referred to as a paddle bit or a spade bit. They're inexpensive, they're reasonably accurate, and they're also very easy to resharpen when they get dull. And they typically have a really long reach on them. When you're shopping for paddle bits or spade bits, make sure that you're buying the best quality that is available, and look for ones that have a hexagonal shaft rather than a smooth shaft on them. They will perform much better. There'll be less likely to be any slipping between the bit and the chuck. So these paddle bits rely on there being something for this center point to engage in. So one of the important things to understand about paddle bits is that you cannot come back into this hole now and drill a larger size hole out with another paddle bit, because it would just bounce around in that opening, because it needs that hole, that center point, to stabilize the bit and guide it. So we can step down in size, but we cannot step up in size when it comes to using paddle bits. This will also give me a guide hole that will allow me to come in with my next drill bit size, and that next drill bit size is slightly larger than the widest point under the shoulder of the head. And the reason that I need this to be slightly larger is because wood has the ability to expand and contract laterally up to 1/4 inch over 12 inches of width. And if we simply screwed all the way through both pieces that means that we're restricting the top piece's ability to respond to those lateral movements that can result in cracks along the grain of the material, especially when you have all of these bolts lined up on the same line. So I want that oversized hole so that the lag bolt literally drops through the first piece of material. And then lastly, I'm going to come through with my third bit, which is the width of the diameter of the shaft less the threads. So if you don't have veneer calipers like these, which again, very inexpensive and very useful tool for measuring inside dimensions of holes, measuring the outside diameter of things, and also for being able to measure the depth of things. So it's a very versatile, very useful tool. Failing having that, you can just hold your screw and your bit in parallel with each other and see how they match. I'm still going to drill a test hole every time to make sure that it's not oversized, resulting in a loose fit, or undersized, resulting in too much stress on the materials, predisposing it to splitting later on down the line. So 3 bits are involved in this process. I've done all the holes but one, so we'll go through knocking out that hole in just a second. Let's jump backwards for just 1 minute and look at the layout, which I probably should have started with. I mentioned before that you could do almost everything you need to do using a tape measure like this, right? So I could come from the end of my material, as I did here, and measure a few inches in from the end to minimize the chance of splitting. I came in 3 inches, and then I'm hitting these on 12-inch centers all the way down the line. And I'm doing this so that it is predictable, so I know where these are, because this will be the backside, and I will be blind to that once I flip this over and attach to the wall. So I really want to know where those are. So I could come in and I could just measure all these out, and then I could come in from the side and I can measure and mark the center point of the material that I'm intersecting with on edge. But this is where I really like that speed square, right? Because the speed square allows me to be able to strike long lines across from either side like this. And that's the simple function of it. But the more useful part for layout like this is that I can actually go to these notches along the inside of the body of this that correspond to the fractions that are most commonly used for laying out and framing dimensional lumber like this: 2x4s, 2x6s, 2x8s, 4x4s. And by going into this corner, I can slide this down the length of my material, and that marks my intersection right on center where I want to be. So it's a really fast and efficient tool. And I think I might have talked about this in the tooth cutting module, but the other thing that's really nice about speed square is that I can use that to run the base of my saw up against as a guide to keep my cut straight, using this as a point of reference. So again, speed square, great tool for rough framing and for layout. So for what I'm going to do, oh, I'm sorry, one other thing. The hole size that I'm drilling to create this pocket is not just to accommodate the washer, but I need it to be able to accommodate the drive system that is going to secure that fastener in place. So my measurement for this was actually based on the width of the socket that I'm using, so that I knew that I could get down into that opening with enough room to be able to tighten that in place. So let's get our eye protection on. Let's get our bit set up. We're going to tighten that up into the chuck. I'm going to be working with high speed in the drill setting. That's giving me 100% of the power of that tool. Oh, here's a nice little rig that I came up with this morning. I've set up a dust collector that's from a downdraft table that I built, and I've modified it so that I can use it for collecting dust at the point at which it's being generated. Let's see how efficient this is. And this was made by taking a commercially produced telescoping rubber fitting that is typically cut down to accommodate different hose sizes, and I've mounted that to a Cafe Bustelo coffee can, which fits absolutely perfectly into a standard 4-inch flexible hose that comes off of my dust collector. How's that for spanky, right? So I'm going to go ahead and fire up the dust collector. It's getting a little bit noisy, and we're going to pop out those 3 holes. I've made a mark on my drill bit to indicate my depth of penetration. I could also use a piece of tape. Okay, so step 1 was deep enough to allow this to pocket down inside of the material, leaving enough material behind to have the strength to resist this tearing through. My second hole is for the drop through the first piece, so it just slips right in there. And my third hole is for the threads to bite into the second piece, so that my top is being pulled down my bottom instead of the 2 threading together. I've put a driver socket on the end of my cordless driver. So now I'm going to turn this down to driving. I'm going to go from high speed, which I use for drilling, to low speed, which gives me high torque. I'm going to set this for about 13. And my clutch engaged, and now I'm going to finish by just hand cranking that. We looked at clamps being used to pull down the materials to be flush to each other, but you can see I also have a clamp here, and that's because this piece was a little bellied out, so I use this clamp to push that back in so I've got a good flush fit between those 2 pieces.